right, hello. We have started our Unit 4 on lines in our algebra class. So day 1, we're going to talk about slope again. And a lot of this is going to feel familiar because we just talked about slope when we were using our equations and equations of the line in our functions unit. So some of this will seem familiar and some of it might seem new. All right, so just a reminder, a linear equation, when we're using the phrase linear equation, it's just an equation that you can use to quickly produce a line when you are graphing the line. It means that for any x that you plug in, you'll get a y, and all of the x, y points will create a line and not a curve or something like that. All right, so let's look at slope. We're thinking about slope. Slope is also rate of change, and that's just an important distinction. We want to know that if we're reading a word problem and we hear about rate of change, we know that we are thinking about the slope. Okay, so rate of change is a rate that describes how one quantity changes in relation to another. We usually see this in problems that say, I am going to charge $4 for each pie that I bake and sell at the bake sale or something like that. Whenever you have for each or for every or per, that usually is going to be your rate. All right, x is the independent variable when we're thinking about our two variables. Y is the dependent variable. That means when I'm thinking about a word problem, I'm going to think this depends on that. If I can figure out which is the dependent variable, that's going to be y. X is the independent variable, and almost always, if we are talking about time, time is the independent variable. Almost always, just so you know. All right, so again, we're going to always think to ourselves, which variable depends on the other thing? Y, the y variable always depends on the x, right here. Okay, that means our vertical axis and our horizontal axis here, this is x. Our horizontal axis is the independent variable, and our vertical axis is the dependent variable. All right, so slope, when we're talking about slope, it represents the rate of change in our y values divided by the rate of change, divided by the change in our x values, is a better way to say that. So we're going to think about slope as the change in y over the change in x. Okay, we're making a fraction where we have the change in y divided by the change in x. It measures the steepness of a line. So you can think that the higher the number, the steeper the line will be. All right, if your slope is positive, if it's a positive number, then both quantities are increasing together. And you're going to get a positive slope like in this graph. It is going uphill. As you look from left to right, we're going uphill. If your slope is negative, it means that one quantity is going up while the other is going down. And so this would be a downhill slope right here. That's a negative slope. Okay. And as we say, if we're sledding on a slope that looks like this, that's completely flat, we will have zero fun. The value of that slope, the number that represents the slope, is 0. Okay, a positive slope might have a number like 2/3. Okay, it might have a number like 5. As long as the slope itself is a positive number, you're going to be going uphill. If your slope is going downhill, it's going to have a negative number, so I might have -1/2, I might have -6, but we're always representing slope with a number, unless we have a vertical line like this guy. Okay, and if you had pre-algebra or Math 7 honors last year, you may or may not have talked about a vertical line. A vertical line, when you try to do the math for this slope, your change in x, the denominator, is going to be 0, and we're not allowed to do that. So we have to say that a vertical line has an undefined slope. There is no number that represents that vertical line for the slope. Okay, and again, we're always reading our graph from left to right, while the same way that we read books and words and things in American English, or any English, really. All right, there are some special cases that we may or may not have described in this way that we're going to describe them on this set of notes. So a vertical line, you know that it has an undefined slope because we just talked about that. And I could give you examples. If this was at 1, 2, 3, let's just pretend that we have a point here at 3, 0. And 1, 2, let's pretend we have a point here at 3, 2. If I find that slope, I'm going to say y sub 2 minus y sub 1, that's negative 2, over x sub 2 minus x sub 1, 3 minus 3 is 0. So no matter what I do, I end up with a 0 in the denominator, and so that's why my slope is undefined. Okay, a vertical line has an undefined slope because there's no change in x, which makes the denominator 0. All right, so if I want to write the equation of a line, in this case, we're going to say x equals some number. Okay, remember that if I have some sort of a line like this that has a positive slope, I could write that with y equals mx plus b, where m is the slope, and b is where I cross that y-axis. That is my y-intercept. If it's a positive slope, my m is going to be positive, a positive number, and if it's a negative slope, my m is just going to be a negative number. Okay, so most of the time when we see the equation of a line, it's going to look like y equals 2/3 x plus 1 or something like that. But if I have a vertical line, I'm just going to have x equals some number. Okay, if you look here, this is my vertical line. This point, x equals 3, y equals 0. This point, x equals 3, y equals 2. This point, x equals 3, y equals 3. This point, maybe x equals 3 and y equals negative 1. What you can see is that every single x equals 3 in that vertical line. So for my line up here, I might say x equals 3 if I wanted to write the equation of the line. All right, so if I'm talking about a vertical line, we use vux. And if I talk about a horizontal line, we use hoi. So we're going to say vux hoi. Vux tells me that a vertical line, v for vux, v for vertical, has an undefined slope, that's where I got that u, and x equals some number. In my example, x equals 3. For a horizontal line that goes side to side, I know that my horizontal line has a slope of 0. So yes, I'm saying hoi, and I'm pretending like it's the letter O, and I understand that O and 0 are different, but we are focusing on the fact that it looks like a 0. So a horizontal line has a slope of 0, and y equals some number. So I might have y equals 6, or y equals negative 2. I'm going to have a horizontal line that crosses the y-axis at some number. Okay. So down here, the horizontal line has a slope of 0, we talked about. There is no change in y. We are not going up or down when we have a horizontal line, right? I never go up or down from one point to another. But I do change as I'm going from left to right. So my denominator will have some sort of a value.